at the right time. So today we are going to discuss and start with the topic of arithmetic, that is called speed, time and distance. Okay. So speed, time and distance is one question type that you can find around 1 to 2 questions in the prelims paper as well as the mains paper of IBPS PO examination. So our goal for today's class is to discuss the core concept, the basic concepts of speed, time and distance. We are going to divide this topic into 3 sessions. In the first session, we are going to talk about the core concepts, the elementary concepts of speed, time and distance, the basic concept of unit conversion, as well as understanding the ratio methods involved in speed, time and distance. The second session will be where we will be discussing with you the concept of relative speed and concepts on trains, and the third session will be where we will be discussing with you the concepts of boats and stream. So starting with the first session today, let's see, before we go to that, let's just quickly cover the concept of the problem from previous CPP, that is the previous question from class practice pack. Now this is a question from the topic of time and work, and here we have Ajay can complete a work in 12 days, Ajay and Suresh can do the work in 8 days, Suresh and Bipin can do the work in 10 days. How many days will Bipin take to complete the work alone? So see here, Ajay is taking 12 days, Ajay and Suresh, so A plus S, can complete the work in 8 days, and Suresh and Bipin can do the work in 10 days. 12, 8 and 10. That is why we have taken that let the total work be LCM of these numbers. So this is one of the methods for solving time and work efficiently without using that 1 by 12, 1 by 8 thing. The one simpler approach is to take the total work as LCM of 12, 8 and 10, the least common multiple of 12, 8 and 10, which is 120. So we say let the work be 120 units. Now if the work is 120 units and Ajay can do the work in 12 days, then in 1 day Ajay can do how much work? So you can divide 120 by 12 and that is equal to 10. That's how we have got Ajay's per day work. 10 units of work Ajay is doing on a per day basis. Similarly, dividing 120 by 8, that is equal to 15, we have got the work done in 1 day by Ajay and Suresh combined. Ajay can do 10 units in 1 day, Ajay and Suresh combined can do 15. So subtracting 15 minus 10, we get the units of work per day for Suresh. Now Suresh and Bipin can do the work in 10 days, dividing 120 by 10, we get 12. That's how we have got this 12 units per day for Suresh and Bipin, out of which Suresh per day work is 5 units. So Bipin we can find out by subtracting 12 and 5, that's how we get 7 units per day for Bipin. And the total time taken by Bipin, how many days will Bipin take? 120 by 7 or 17, 1 by 7 days. That is how we have got the answer for the question from previous CPP, that is from the topic of time and work. Okay. Okay, alright. Now let's start with the concept for today's session of speed, time and distance. So for speed, time and distance, the basic formula is that speed into time is equal to distance, right? Speed into time is equal to distance. If we know the speed at which an object is travelling and if we know the time for which the object is travelling, multiplying them we can find out the distance covered by the object. So normally speed is given to us in kilometers per hour, time in hours, and if speed is in kilometers per hour and time in hours, distance will be in kilometers. Okay, these are the standard units of speed, time and distance. Another unit that is used in some questions is that speed is in meters per second, time is in seconds, and distance is in meters. So the units that we get in questions are either in kilometers per hour or meters per second. Occasionally in some questions, we need to convert from one unit into the other. So for example, in a question of trains, if they say that a train 110 meters long, right, and it's moving at a speed of 40 kilometers per hour, how much time it will take to cross an electric pole? Clear? Now the length of the train is in meters, the speed of the train is in kilometers per hour. So we cannot directly use the two values and get the answer. We have to convert kilometers per hour into meters per second, or we have to convert the length of the train from meters into kilometers. So what we do is we have to understand the concept of unit conversion. How do we convert from kilometers per hour to meters per second, right? So for that we have to understand that 1 kilometer is equal to 1000 meters and 1 hour is equal to 60 into 60, that is 3600 seconds. Cancel the zeros and divide by 2, we get 5 by 18. So we can say 1 kilometer per hour is equal to 5 by 18 meters per second, and the converse we can say that 1 meter per second is equal to 18 by 5 kilometers per hour. That means if you want to convert speed from kilometers per hour to meters per second, you need to multiply the speed in kilometers per hour with the fraction 5 by 18, and if you want to convert from meters per second to kilometers per hour, you need to multiply with what fraction? 18 by 5. And this you will remember as a rule. You should know how we got the fraction, but you should also remember the rule for unit conversion, so that tomorrow when you have to convert from kilometers per hour into meters per second, you can do it without any difficulty. Alright. So that's the first thing that we are learning today. One is the formula of speed, time and distance. Speed into time is equal to distance. So we can say speed is equal to distance by time, right? Speed is equal to distance by time, and time is equal to distance by speed. Time is equal to distance by speed. So same thing, speed into time, distance. Speed is equal to distance by time, and time is equal to distance by speed. Understanding the units and know how to convert from one unit into the other. So let's take this question here. A car is moving at a speed of 10 meters per second. How much time will it take to cover 72 kilometers? So the car is moving at the speed. So what is the speed of the car? Speed of the car is 10 meters per second, and a distance to be covered is 72 kilometers. How much time? We have to find out the time taken. So what is the formula for time? Time is equal to distance by speed. Time is equal to distance by speed. Now here distance is in kilometers, whereas speed is in meters per second. The units don't match. So what we do? We convert speed into kilometers per hour by multiplying 10 meters per second. When you have to convert from meters per second to kilometers per hour, you multiply with 18 by 5. So if we cancel this, you get here 36 kilometers per hour. So that means 10 meters per second is same as the speed that we say 36 kilometers per hour. So, time is equal to distance 72 divided by speed 36. So, distance 72 kilometers, speed 36 kilometers per hour, dividing we get 2 hours. So, what is the time taken? Time taken to cover this distance is 2 hours. So, this is just a very basic example to understand the application of the formula of speed, time and distance, and also to see how and when we convert from one unit into the other. Alright. Now, continuing with the concept of speed, time and distance, the next thing that we have to do is to understand the ratio method or the ratio concept for solving questions on speed, time and distance. When I say speed into time is equal to distance, and when you learn the basic formulas of speed, time and distance, that is more or less sufficient for you for solving any question, no matter of what difficulty level. Everything extra that we are learning, everything additional that we are learning is only to simplify the problem solving process. Okay. So, ratio method, the first thing is when speed is constant, when speed of an object is constant, speed is constant, that means an object, a car, a body is travelling at a uniform speed. So, what type of speed we are talking about? Uniform speed. Okay. So, if an object is travelling with a uniform speed, we say that distance covered is directly proportional to time. Distance is directly proportional to time. This symbol here is the symbol for direct proportion, and that means if time is increased, the distance covered will increase, and if time is decreased, the distance covered will decrease. So, we get the formula here, d1 by d2 is equal to t1 by t2. So, this will be the formula to use when the speed of an object is constant. Distance covered by the object is directly proportional to the time that the object travels. So, two cases are given to you, d1 and d2, that is one case, and t1 and t2, that is the other case, right. If three values are known, we can substitute the value here and find out the fourth value, the unknown value. Okay. So, ratio of distance is equal to ratio of time, that is when speed is constant. Second scenario is when time is constant. Two objects or one object is travelling for a fixed time. Let us say every day you go from your home to college or work, right. You cover a fixed distance every day. Clear? You are now, let us see, you take 1 hour. Let us keep a time constant. Let us say you are travelling for 1 hour. If you travel for 1 hour in a car, the distance covered will be, let us say, around 40 kilometers. If you travel 1 hour in a bicycle, the distance covered will be around 18 kilometers. If you travel 1 hour in a flight, distance covered will be almost 400-500 kilometers. So, when the speed is increasing, distance covered is increasing, and when the speed is reducing, distance covered is reducing. So, we can say that when time is constant, speed is directly proportional to distance. More speed, more distance, less speed, less distance, right. So, that is the thing here. Speed ratio S1 by S2 is equal to distance ratio d1 by d2. This is the formula that we have to keep in mind regarding the second concept, that is when time is constant. When the time is constant, then distance becomes directly proportional to speed. Ratio of distance is equal to ratio of speed. Okay, that is the second situation. Now, we will take the third situation. The third situation is when distance is constant. When distance is constant, then what happens? So, if you are covering a fixed distance, every time you are traveling, covering a fixed distance, let us say you are going from your home to work every day, a fixed distance you are covering. If you travel with greater speed, then the time taken will be less. If you travel at a slower speed, time taken will be more. So, when speed is increasing, time is reducing, and when speed is reducing, time is increasing. So, what does it mean? It means that speed is inversely proportional to time. This is how we write. Speed is inversely proportional to time. Alright. So, from this we get the formula S1 by S2 is equal to T2 by T1. That is the third scenario for ratio method. So, three things are there. We see, one is when speed is constant, when speed is uniform, speed is fixed, then distance ratio is same as time ratio, or we say distance is directly proportional to time. D1 by D2 is equal to T1 by T2, where D stands for distance and T stands for time. Second is when time is constant, then speed is directly proportional to distance. S1 by S2 is equal to D1 by D2, okay, where S stands for speed and D stands for distance. Third is when distance is constant. When distance is constant, speed is inversely proportional to time. So, S1 by S2 is equal to T2 by T1. Okay, so this is the third thing. Three formulas are there. Now, let us take one example question here. Two trains start from opposite stations A and B at the same time. The train from A reaches B 9 hours and train from B reaches A 4 hours after crossing. The distance between A and B is 300 kilometers. What is the respective speeds of the train from A and B? Look at the question, take some time, try to make a diagram or something to form the question, and then we will see how you get the answer. Which of the ratio concept will be applied to get the answer for this question? The two trains start from opposite stations A and B. The train from A reaches B 9 hours and train from B reaches A 4 hours after crossing. If the distance between A and B is 300 kilometers, what is the respective speed of the trains? Close it. Alright, so let's first here make a diagram to understand what is happening in this question. Two stations are there, A and B. A train is starting from A moving towards B. What is the speed of the train? We don't know. Another train is starting from B moving towards A. So, two trains start from opposite stations A and B at the same time. That is also very important here, that the trains must start at the same time. The train from A reaches B 9 hours and train from B reaches A 4 hours after crossing. Let us say they cross at this point X. So, after crossing, train from A covers this distance in how much time? 9 hours, and train from B covers this distance in 4 hours. and the total distance between A and B is 300 kilometers. What is the speed of the train from A and what is the speed of the train from B? How do we calculate and get the answer? We will see systematically everything here, how it is being done. First of all, let us talk about the point when they meet, when the two objects meet. Remember this, that when two objects start at a time and meet at a particular point, the time taken by both objects is always same. Let us say for example, you start from your home at 10 o'clock and your friend also starts from his home at 10 o'clock. Both of you start at the same time. You are traveling in a car and your friend is walking, right? Both of you start at the same time, that is 10 o'clock, and meet at 10:30. So how much time have you taken? 30 minutes. How much time has your friend taken? 30 minutes. Time taken by both is same, but have both covered the same distance? No, right? You were traveling in a car, so distance covered by you would be more as compared to your friend who is walking the entire time. Okay, so distance can be different, but time is same. All right. So when we look at the first case, when they meet at point X, time is constant. When time is constant, what happens? Which ratio concept is applied? When time is constant, then speed is directly proportional to distance. So let us say speed of A upon speed of B is equal to distance covered by A upon distance covered by B. Speed of A upon speed of B is equal to distance covered by A upon distance covered by B. We do not know what is the speed of A, we do not know what is the speed of B, right. Now let us say A has covered this distance, travelling from the train from A has covered this distance. Let us call this distance as dA, and B has covered this distance. Let us call this distance dB. Now this is the distance covered by A and B at the point of meeting. After that what happens, we will see that later. At the point of meeting, that is X, A has covered, the train from A has covered from here till here, we are calling this distance dA, and the train from B has covered this distance, we are calling it dB. Okay. So we can say, now you see what happens after crossing. After crossing, the distance that we are right now calling as dB, this distance is covered by A in 9 hours. So we can say dB is equal to SA into 9. Similarly, after crossing, this distance that we are calling as dA is covered by B in how much time? 4 hours. So distance A is equal to speed of B into 4. Please understand. So let us see again. At the point of meeting, A has covered distance dA and B has covered distance dB. So ratio of speed is equal to ratio of distance, because time is constant. SA by SB is equal to dA by dB. Now the distance dB is covered by A in 9 hours. That is how we get dB is equal to SA into 9, and distance dA is covered by B in 4 hours. This is after meeting, right. So I can say that SA by SB is equal to dA by dB, where dA is SB into 4 and dB is SA into 9. So when you cross multiply, SA goes this side, SB comes this side, we get SA square by SB square is equal to 4 by 9, or we can say SA by SB is equal to under root 4 by 9. SA by SB is equal to under root 4 by 9. So that is equal to 2 by 3. So what we get here is a ratio of speed. Speed of A is to speed of B is 2:3. So we can say let the speed be 2x and 3x. Distance dA is equal to SB into 4. 3x into 4, that is equal to 12x, and distance dB is equal to SA into 9, that is 2x into 9, that is equal to 18x. dA plus dB is equal to 30x, which is equal to 300, because we know that the total distance is 300, or x is equal to 10. So speed of A is equal to 2x 20 and speed of B is equal to 3x, that is 30. So we can say here that A is 20 kilometers per hour and B is 30 kilometers per hour. This becomes your answer, right? Now every time you get this question, you don't have to do the entire thing like the way here. This is for understanding concept, right? So understand every step that we have done here, how we have taken time constant and taken the ratio of speed and distance, then working it out how we are representing distance dA dB separately as SA into 9 and SB into 4, using that to get this ratio. SA by SB is equal to under root 4 by 9, and then using ratio to get the answer. So every step should be clear to you. Now if you get the same question again in an examination, what you can do is directly remember the formula, that SA by SB is equal to under root TB by TA. In this type of question where two objects start from A and B, and the time taken by the two objects after crossing to reach their respective destinations is given to you. So TB and TA here stand for time taken after crossing. Yeah, that's very important to understand. Time taken after crossing, TB and TA. So using this formula we can directly say SA by SB is equal to under root TB by TA 4 by 9, that is 2 by 3. Let the speed be 2x and 3x, and then using that we can solve the question and get the answer. Okay. Now another shortcut technique that's really fast to solve this question. You understand this? What is given to you? Two trains start from A and B. They cross at a point, and after crossing, train from A takes 9 hours and train from B takes 4 hours. The fastest way of solving this question, you multiply 9 and 4, 9 into 4, how much is that? 36. Take the square root of 36. What is the square root of 36? 6. Write down 6 here and 6 here. 6 plus 9 is how much? 15. So A has taken 15 hours. The speed of A is equal to 300 by 15, 20 kilometers per hour. And B, 6 plus 4, what is 6 plus 4? 10. So B has taken 10 hours. Speed of B is equal to 300 by 10, that is 30 kilometers per hour. That is how you can find out directly by using this technique. Remember, the time taken after crossing, multiply these two values 9 and 4, get 36. Take the square root of 36, 6. Write down 6 here and 6 here. Add 6 plus 9, 15. A has taken 15 hours. 6 plus 4, 10. B has taken 10 hours. 300 by 15 is 20. 300 by 10 is 30. Alright. Now we will see the contest question from the previous class on direction and distance. What is given to you is that south west is north. Correct? The direction is not changing. The name of the direction is changing. Southwest is northwest. Then sun rises from which direction? We know that sun rises from east. But what is east in this particular situation? If southwest is northwest, then what will be east called? So let us see here. This is southwest, and now we are calling it northwest. From northwest, when we go 45 degrees anti-clockwise, we get west. This becomes west, this becomes east. Opposite of west is east. If this is east and this is west, then this will be north, because if east is in your right, then you are facing north. Or from east, when we go anti-clockwise, we get north. And what is opposite north? South. But this south that we are calling south right now, in the actual direction, that is nothing but east. Understand this? What is this? Actually east. But what are we calling it? South. So sun rises from which direction? The answer will be based on the information given. Sun rises from the south direction. Alright. That is the method of solving this question of direction sense. Now taking today's contest question. To work from home every day, if he travels at a speed of 5/3 meters per second, he is late by 30 minutes, and if he travels at a speed of 8 kilometers per hour, he is early by 10 minutes. What is the distance of his home from office? Okay. The question is on the screen. You can try solving the question and post the answer in the comment section. A person travels to work from home every day. If he travels at a speed of 5/3 meters per second, he is late by 30 minutes. He is not reaching on time, he is reaching late by 30 minutes. And if he travels at a speed of 8 kilometers per hour, he is early by 10 minutes, before time. Using this, can you find out what is the distance of his home from his office? Okay, so you can try solving this. I will be discussing this contest question in my next session of speed, time and distance. So I will move on to the next slide. So again, let us take a question here. So ratio method we have discussed. From the ratio method, one question we have seen, that is two trains or two objects starting from 2 points, opposite points, crossing, and the time taken after crossing is given to us. Now let us see this question. Now this is very similar to the contest question that I had given to you. So if you understand this, follow this, you can solve the contest question on your own. A student goes from his home to school every day. If he travels at the speed of 3 kilometers per hour, he reaches late by 10 minutes. Whereas if he travels at the speed of 4 kilometers per hour, he reaches early by 10 minutes. What is the distance from his home to his school? So you see here, he is going from home to school every day. If travels at a speed of 3 kilometers per hour, he is late by 10 minutes, he is late. And if it travels at a speed of 4 kilometers per hour, he is early by 10 minutes. What is the distance from his home to school? In this case, if you look at the ratio method, you will understand that in this case distance is constant. What is constant here? Distance. Distance is constant. If distance is constant, what happens? Speed is inversely proportional to time, or we get S1 by S2 is equal to T2 by T1. In this case, we know this is our S1, this is our S2. What is T1? What is T2? So let us say that the actual time is T. Let us say that actual time is equal to T minutes. Then time taken in the first case will be equal to T plus 10, because he is late by 10 minutes, and time taken in the second case will be T minus 10. because he is early by 10 minutes. So we can say 3 by 4 is equal to T2, that is T minus 10, by T1, that is equal to T plus 10. Now I am not converting here the time from minutes into hours. You don't need to do that, because in ratio the unit will get cancelled, it does not matter, right. So directly we can say 3T plus 30 is equal to 4T minus 40. Taking T on one side we get T, 4T minus 3T is equal to 40 plus 30, 70 minutes. So actual time is 70 minutes. So T2 will be equal to how much? 70 minus 10, 60 minutes or 1 hour. Speed is how much? 4 kilometers. Time is how much? 1 hour. So distance will be 4 into 1, that is 4 kilometers. That is how you solve this question to get the answer. Alright, 4 kilometers. Now there is a shortcut trick for solving this question that I will be discussing in this slide now. Same question, but what is the shortcut technique? Distance is equal to S2 into S1 by S2 minus S1, right, into delta t, where delta t stands for change in time. Delta t is change in time, right. So suppose actual time is t, you are changing it to t plus 10, 10 minutes more, 10 minutes less. So the actual change in time is 10 plus 10, 20 minutes, and 20 minutes is equal to 1 by 3 hours. Now here we need hour because we are multiplying. What happened to this entire thing? So let's start from here, no? Okay. So look at the one second, we'll be back. Yeah. So distance formula again I am writing here. Distance is equal to S2 into S1 by S2 minus S1 into delta t, where delta t stands for change in time. Change in time. And how do we calculate change in time? So if we take t as a time, see how much more it is, t plus 10, 10 minutes extra. How much early? T minus 10. So the difference between these two will be how much? 20 minutes. Let's say you have to reach somewhere at 8 o'clock and you reach 10 minutes late, you will be reaching at 8:10. 10 minutes early, 7:50. So the gap between 8:10 and 7:50 is 20 minutes. So 3 into 4, so 4 into 3 by 4 minus 3 into 20 minutes is equal to 1 by 3 hours into 1 by 3. So 12 into 1 by 3, that is equal to 4 kilometers. So directly we will get the answer if you use this particular formula of distance equal to S2 into S1 upon S2 minus S1 into delta t. Alright, okay. Now let's see the next question. If a man walks to his office at 5 by 4 of his usual rate, he reaches office 30 minutes early than usual. What is his usual time to reach office? Okay, let's see. This question will solve in a very simple method, that is based on the concept of increase and decrease when distance is constant. When speed into time is equal to distance and distance is constant, because it is traveling, this covering same distance. He is going from home to office. Speed is increasing. If speed goes up, time will come down. We know speed and time are inversely proportional. If speed goes down, time will go up, and there is a formula for increase and decrease. If increase is a by b, decrease will be a by b plus a, and if decrease is a by b, then increase will be a by b minus a. This will help you in solving questions like the one you see on the screen within maximum 10 seconds. So you see here is walking at 5 by 4 of his usual rate. So 5 by 4 is nothing but 1 plus 1 by 4. So that means his speed has increased by 1 by 4. Increase is 1 by 4. So decrease, that is time, will decrease by 1 by 5, a by b plus a, and 30 minutes earlier, right. So if speed is increasing, time will reduce by how much? By 1 by 5. So 1 by 5 of whatever time he was taking earlier is equal to 30 minutes. That means the time that he was taking earlier is equal to 150 minutes. 150 minutes is equal to 2.5 hours. So answer is 2.5 hours. That is the answer for this particular question, and the concept is that if speed is increasing, time will reduce, and if speed is reducing, time will increase, and this increase decrease are related. If increase is a by b, decrease is a by b plus a, and if decrease is a by b, increase is a by b minus a. So see a similar question to this. Let's take this example. A train does the journey without stoppage in 8 hours if it had travelled 5 km per hour faster. It would have done the journey in 6 hours 40 minutes. Find its original speed. Different ways are there, we can solve it directly also. Let us say the original speed is s and the time is 8, so distance is equal to s into 8, clear. Also we can say that if he is travelling 5 kilometers per hour faster, s plus 5, that is doing the journey in 6 hours 40 minutes. 40 minutes means what? 40 by 60, 2 by 3 of an hour. 6, 2 by 3 of an hour is nothing but 20 by 3 of an hour. Okay, so 20 by 3. Distance is same. That means this first equation and second equation will be equal. 8s is equal to s plus 5 into 20 by 3, or 8s is equal to 20 by 3s plus 100 by 3, or we can say 8s minus 20 by 3s is equal to 100 by 3. 24s minus 20, that is 4 by 3s, is equal to 100 by 3. 3 gets cancelled, s becomes equal to 100 by 4, that is equal to 25 kilometers per hour. But this is not the best way of solving the question, right. So what we do is to understand and solve this question by increase decrease concept. Just now we have discussed increase decrease. Earlier it was taking 8 hours, now 6 hours 40 minutes. That means 1 hour 20 minutes less. 1 hour 20 minutes less. 1 hour 20 minutes means how many minutes? 80 minutes. Compared to his original time of 8 hours or 480 minutes, that is equal to 1 by 6. So time is reducing by 1 by 6. Speed should increase by 1 by 6 minus 1, that is 1 by 5. 1 by 5 of something is equal to 5, because we know a speed increased by 5. So x is equal to 25 kilometers per hour. So you can see here the time taken to solve in this case and time taken to solve in this case. What is the difference that you should observe? Why we have to learn faster methods and easier methods of calculation? Because in examination we don't have sufficient time to solve questions. Alright. So we have completed the first session of speed, time and distance, where we have understood the basic concept of speed, time, distance, unit conversion, and ratio methods and some shortcut techniques of solving questions. Next session of speed, time, distance will be discussing relative speed and concepts of relative speed. Now is the time for CPP. So those who have passport access, once you hear the sound, you can start solving the CPP questions, and the questions that most of you get wrong, I will be discussing in my next session of speed, time and distance. So best of luck to you. Start solving the questions now.